All right, welcome everyone. So, by show of hands, how many of you have sat through conference talks thinking, I wish they'd answered the question that I wanted them to answer? Okay, so today we're going to flip the script. It's going to be completely different.
This isn't just another talk, it's the Cloud Native Wheel of Fortune, and you will have the opportunity of contributing one topic on top of the others that we prepared in our Wheel of Fortune.
And that's just the beginning. So we're going to spin the wheel. You're going to have 4 chances to be able to, select topics, but you're also going to get the chance to ask us a question.
Think of this like speed dating for Cloud Native. So we'll give you the essentials on every of the topics, and then you're going to reach it with your answers.
So before we spin the wheel, I'm Steve Wade. I'm a Cloud Native Catalyst from the UK. My background is really in platform engineering, from running large-scale Kubernetes clusters to debugging service meshes and kind of everything in between.
I'm Matteo Bianchi. I'm a CNCF ambassador. I work as a solutions engineer at GitHub, and I'm a lazy engineer. Well, I like to automate stuff. So from CI/CD and everything else in between, now please scan your Slido. We have 100 spots, so it should be enough. If you're not in, it's still fine. These are the topics that we have. We have already AI, ML, eBPF, Kubernetes Release Team. Do not put those already, because we have them already in the wheel. And please be as nice as possible. Do not put quantum computing. Now that I say it, like everyone's putting that.
So we're going to give you about 30 seconds.
Oof.
The one that has the biggest cloud is essentially the one that we're going to spend the next 5 minutes talking about.
Nice.
So this is you guys getting to decide what we're going to talk about for the first 5 minutes.
I like air-gapped. Platform engineering is already on the wheel.
All right. Platform engineering and GitOps is already on the wheel.
British food. That's
British food.
That's a nice topic.
We can talk about British food if
Best
that's what
beer
people want to
brand,
talk
yes. I like that. Network isolation, okay.
All right, choose a topic.
I would say,
Go on.
air-gapped.
All right. All right, so we're going to talk about air-gapped environments. So hands up, those of you who have been running Kubernetes clusters in air-gapped environments. Hands up if you enjoyed that experience. Okay, so probably the most interesting example that I can remember is when I spent a long time in a financial institute. And fully air-gapped, and by fully air-gapped, I mean like you weren't even allowed to take USB sticks in. It was very, very highly regulated. And one of the interesting things that we had to do is you can bootstrap Kubernetes, right? That's a relatively well-solved problem. However, you need to somehow get the images that are required to be able to run Kubernetes somewhere for you to be able to leverage them. So the hardest thing for us was to get the ability for those images to exist somewhere that was or wasn't on a Kubernetes cluster itself. So the interesting concept that we tried to come up with was really where do we deploy this image registry that's going to be leveraged to be able to bootstrap all of our Kubernetes clusters? And it turns out that that was actually a much harder problem than actually being able to bootstrap a Kubernetes cluster itself. I think it's still an interesting question about where we go in terms of there are so many registries that we could leverage, right? But how do we make sure that the images that we leverage are secured? We've got attestation, we've got provenance, et cetera, right? We can talk about SBOMs all day, every day. But how do we make sure that all of the images that we use, even to bootstrap the cluster, have gone through some level of provenance? And luckily, in future and relatively new releases of Kubernetes, they have released these SBOMs in order for us to be able to leverage.
So I would say that there are different levels of air-gapped. I worked in a semi-air-gapped environment before where you could download stuff, but you could not have any data go out of the network. That is, I think, a sweet spot for some applications. Like, again, if you had a registry, like you could still download the images. Maybe you want to have a 0 CVE style image. And then, well, you don't want to have any data going out of the network. I would say that networking is the most difficult part when you are dealing with an air-gapped environment. Everything else is pretty much the same. Sometimes you also have resource constraints. Like when you're working at the edge, maybe you're working on vehicles, maybe you're working on different edge devices. I don't know, just a satellite or whatever. I think that some companies here around in the showcase can talk about that. I think that that is the most big challenge when you have resource constraints, and your networking latency also is different. Like when you are up there in the sky, like maybe you cannot really download a lot of data, you cannot really have all of the goodies that you have in the cloud. So to tackle air-gapped environment, there's no one-fits-all solution. I would say that it's a mix of being savvy enough to deal with the networking issues and, well, praying, as we said before, like just send a nice prayer before doing that. And, well, you can work with specific systems like, I don't know, Talos or specialized OS that are lightweight and that are allowed to be immutable. So I think that that's also part of how you can work with air-gapped environments.
Yeah, I think you raised a good point there, right, about scalability. You do have some kind of elasticity, but you're obviously at the mercy of your own data center in order to be able to know how large to scale. Okay, I'm super conscious of time. So
we can start spinning the wheel.
Yeah, let's start spinning the wheel. So we'll go with Matteo first.
Let's see which topic. Oof, eBPF.
All right, eBPF first. Okay, all right, one more.
Cool.
All right, sustainability it is. All right, and for me, what do we have?
Scale.
Oh, yeah.
Service mesh.
Okay, so on your Slido now, there'll be another tab that's for Q&A. Idea being now for every topic we're going to go through, you're going to have your chance to ask us one question. You can upvote questions that are previously there. We'll take the top one, maybe the top two. So yeah, come up with interesting questions that you want to go through.
The first one is eBPF. Perfect. Amazing. So, cloud native complexity skyrocketed in the last few years. And I think there's a gap in how we secure, monitor, and optimize systems at scale. And here's how I learned about eBPF. That is a revolutionary, I think, at least, way to deal with these issues through the kernel, but without being a kernel developer, without patching the kernel, working in the user space, but still providing a sandbox to attach programs to the kernel space. I gave a talk about this in Salt Lake City at Rejects last year. You can look it up. I explained eBPF to my grandma. I have a series of those talks. And you can take a look for a deeper dive. Today it's going to be a little more on the superficial side. So what you can really do with eBPF, eBPF transforms the kernel into a programmable interface, driving a lot of innovation in the observability space. You might have seen in the project pavilion, Cilium, Falco, some of those projects. Give them a shout out, go and maybe contribute even, which is nice. Think about anything that is tracing, profiling, advanced networking, package manipulation, or deep security application, like anything that goes and really, at the syscall level, scrapes what is happening within your cluster. Unlike the traditional setups, there's no need for, again, lengthy kernel patches or complex workflows to attach a sidecar, maybe. You just work at the eBPF level. One of the difficulties is that, well, it's C development. So if you're not a C developer, there are some libraries that allow you to interact with eBPF in Go, but C is the native way. And, well, in this case, you have the right superpower to save the day most of the time. Industry adoption is growing again, like BPF, with projects like BPF Trace for debugging, of course, Cilium, Falco, and so on. Now, when did I use these projects in a fashion and security environment? I was working for a large fashion company as a consultant. I was a consultant at Steve. And their multi-cloud infrastructure was like more open than a brewed-up pub on a Friday night. So everyone was going in, doing whatever they wanted. They even had like a crypto miner going on in their infrastructure, and they did not notice that. That costed, I think, a couple of millions in infrastructure costs. AWS was so nice to just like forgo the bill. And don't tell it to AWS that I told you this. Under my advisory, they adopted Falco, which is entirely built on eBPF to replace, well, legacy and non-existent, I would say, security tools. I implemented the Falco agent. I deployed it everywhere, even in the VMs, like not only in the clusters. And, well, I started putting up policies, and the performance went really great. They decreased also the security incidents of about at least a quarter, which is still great. They had still some, because they, like, Falco is not the holy grail. You still have your policies, your access, and, yeah, well, they didn't have a VPN, so that's it. Pretty cool thing, of course, was to integrate Falco with their Sidekick and its UI, so you could also, like, leverage all the sending real-time messages on Slack or Teams. Please do not use Teams, based on the security feed. Let's see what are your questions about eBPF, if you have some. In the meantime, check. Is eBPF a universal solution for future projects to leverage kernel operations? I would say it's the first building block. It's fundamental. So it's not 100% a universal solution. There are possibly many more, but it's a good starting point to do monitoring, security, and observability.
So running Kubernetes is relatively straightforward, right, when we've got tens of nodes, maybe hundreds of workloads. But it gets far more interesting when you've got thousands of workloads and tens and thousands of nodes, right? And really, there's a number of things that we need to start to think about here, right? One is the control plane itself. How do we make sure the control plane performance doesn't get degraded at that scale? But we also have to think in terms of the teams that are leveraging these Kubernetes clusters. How can we make their lives much, much easier? So for me, when we're thinking about successful scaling, we're thinking about four things, right? The nodes is, like I said, we focus on the control plane. We can think about virtual clusters. We can think about multi-federated clusters. With regards to teams, it's really how do we make the onboarding experience easier, right? When we've got strong namespace isolation, we've got resource quotas, we've got those network policies. Regions is really about geographical distribution. So do we have a federated couple of clusters that span multiple regions? Do we have singular clusters that are running in different regions? Like, there's a number of options for this, right? And then the final one is really multi-tenancy. So multi-tenancy requirements could be evaluating virtual clusters. It could be providing dedicated control planes. We need to become somewhere with a middle ground, right? You can have a singular cluster that essentially leverages something like vCluster to create those virtual control planes. But then you obviously have that kind of management overhead on top. You've got to manage the underlying cluster, and then you've also got to manage the virtual clusters that are running on top. So a media streaming platform that I was working for that ran out of the Middle East was probably one of the largest clusters that I've actually worked on before. Their suite was over 50 clusters, and it was about 10,000 nodes. And I think it was somewhere in the region of about 150 product teams that were leveraging this. And they hit control plane limits because they tried to deploy everything to one, what I called super cluster. But then they kind of split this up. So their solution combined physical clusters, but with cluster API, with virtual clusters using vCluster. And then they had these custom admission controllers that were used to enforce policies across all of the clusters. They had a very, very complex, that's putting it politely, network policy configuration. I don't know how half of the applications actually got deployed successfully because there was so many of these network policies that kind of stacked on top of each other. But they actually moved to a service mesh that was then used to be able to provide scalable and easily leveraged policies. So they essentially saw it as one big cluster, but it actually wasn't. It was multiple clusters, and they had some fancy ways of being able to deploy their workloads across this pool of clusters. But from a developer experience perspective, they saw it as one supercluster, essentially. And the result was that the platform availability went up, but the ability and need for the developers to understand what was going under the hood actually decreased substantially. And it was really about how can we best support the hundreds of teams that we were leveraging to be able to deploy weekly, but still have the ability to keep the security at some kind of level.
Okay. Let me see what your questions are on scalability.
None.
No questions. Cool. That's also cool.
All right, we'll claim the time back. Your next one.
Or how do you scale for network congestions, maybe?
Yeah, so how do you scale for network congestions? It's, for me personally, it was really about how do we distinguish clusters and their responsibilities, right? Because a lot of people probably think or have a development cluster, a staging cluster, and a production cluster. What we ended up doing was having dedicated clusters that run specific functions. So we had a specific production cluster for function A, and then another cluster for function B, and we tried to minimize the communication between them, and essentially had clusters that were dedicated for certain component types. What's for you?
Sustainability. I already see a question for sustainability. Thank you for putting that in. Cloud native adoption skyrocketed, and of course with this, the need for resources, but all of this has a great impact on the environment, especially with the rise of AI and all of the machine learning workflows that are very demanding in terms of power. In this case, with organizations that are prioritizing, of course, profit, as any organization ever, but they're starting, fortunately, to also prioritize carbon-aware computing. And what does this mean? It doesn't mean just cost efficiency, because that, yeah, cost is part of it, but sometimes you might want to pay a little bit more to get a little bit less carbon. We only have one planet, of course, we need to take care of it, and our impact in tech can actually be huge. Yes, of course, we should still recycle, go on a bicycle when we can, but even optimizing one workflow, even optimizing our code, and thinking about how many CPU cycles are we using, that's more than recycling one bottle. Still do it, please. But yeah, every contribution matters. Now, back to carbon-aware computing. What does that mean? Well, that means three things: carbon intensity, energy efficiency, and measuring impact. So first of all, you need to, well, think about your cloud provider. Do you need to use hyperscaler? Do you always need to use that? Could you go on maybe a minor cloud provider, minor in terms of scale? that maybe reheats across the city some buildings. For example, we have Leaf Cloud in the Netherlands that does this very well. You have Civo in the UK, who's also partnering with another company that has dislocated data centers that allow to use the heat of those for heating houses or public spaces. And with this, you are already reducing your footprint. Aside from this, you should also measure your workload carbon footprint. There are some projects for this. We're going to talk about that later. And there is also, for example, a project that I love, which is KubeGreen. How many of you heard of KubeGreen or use KubeGreen currently? Perfect. 2 hands. KubeGreen is a project that allows you to, well, using the fundamentals of sustainability, turn off your, for example, test environments during the weekend, and then turn them back up on Monday. Same for time of the day. Like, do you really use your test environment from 8 p.m. to 8 a.m. and the next morning? Probably not. So you can turn them off. Of course, this saves also money to your company, which is great, but it also saves resources and carbon that doesn't get emitted in the environment. Now, carbon intensity is not just about cost savings, but it's also about finding the most energy efficient region in a determined timescale where your workflow is using less energy. For example, I was working on a project to reduce the emissions of a company, and I found out that the region in Europe where the carbon efficiency is the best is Sweden. So if you want to use the Swedish region for whatever cloud provider you're using, that's usually the one that has the best and cleanest energy due to the mix of resources they use to produce it. So, in short, embodying practices like this and optimizing the resource footprint of all of your software, using, of course, things like multi-tenancy when possible, leveraging efficient containerization, like even slimming down your containers is greener. It helps, and this is actually the story that I was talking to you about, the carbon intelligence one. And your question was very interesting on Slido. It was, how often project maintainers advocate and enforce sustainable coding practices? In open source, there is less of an incentive, economically speaking, to make workloads more energy efficient and so less expensive in terms of that. I would say that it starts by having a few. So open an issue in your projects and ask what are they doing about carbon efficiency. Go to the current tag sustainability. They have carbon reviews, which is an initiative to measure the carbon footprint of every CNCF project. And like that, we can start and think about green open source.
Cool, so the next topic is GitOps, right? And probably people that are familiar with me know that I kind of rave on about this thing constantly.
The flux person.
The flux person. No, that's Stefan. So we started with infrastructure as code, right? Which was really about how could we define our infrastructure and kind of version control it. But then along came this concept of GitOps, whereby we could start to see Git as our source of truth for the workloads and the configurations that we were leveraging to be able to deploy our clusters. And it was kind of this fundamental shift when this happened about the operational mindset, right? We had to start seeing, hopefully, manual intervention as something that happened less often than probably, the past before that. So when we think about the GitOps sweet spots, to me, obviously, Kubernetes is the obvious one, right? We've got thousands and thousands of lines and files of YAML, and we can kind of circulate them and keep them in a centralized location, whether that be one Git repository or whether that be a multitude of Git repositories split across multiple functions. So maybe you have all of the security features that are owned by the security team in the security repository. You have the releases for product team A and a product team A repo. Multi-cluster consistency becomes easier in my mind, right? We can start to deploy and manage multiple clusters from maybe a singular repository with multiple environment overlays, or the same kind of concept, but with multiple repositories. And really it allows us to be able to see that drift between clusters a little bit easier, right? And we don't have these kind of scary things that are running in staging that have been running there for ages, but we're not really sure what's going on in production. And then finally, for me at least, the most important one is kind of auditability and compliance. I spend a lot of time with financial institutes, and if you've worked in a financial institute, these are the two terms they bang on about the most. So auditability is great when we're using Git. We have a review process, we have approvers, and we also have the ability to be able to provide some kind of compliance report and based off of that Git history. So I'm conscious of time, so I'm going to skip the example and go straight to the question.
Other than telling CD to ignore elements, how can we integrate with projects like Kata? Maybe it was not for GitOps, but
Given SLA. Okay, I can't see one obviously there.
you have to vote them up.
Okay, let's go to here. Where are we?
Please stand by.
So we've spanned through super quickly 5 cloud-native topics, right? And each represents this kind of different facet of the cloud-native landscape. But what you will see is they're all interconnected somehow. Sometimes that's abundantly obvious, but sometimes it's less obvious. And this is the fascinating thing, right? It's really about how these technologies come together. And it isn't a coincidence. It's the power of the ginormous cloud-native ecosystem and the landscape that we currently leverage.
There is one thing away from this tour, which is successful cloud native is not about implementing every new shiny technology. It's about selecting and integrating tools that you already have that are aligned with your specific challenges. The most successful organization we worked with didn't chase any new project announcement, like sometimes yes, but not always. And they built a strategic foundation first, and then based on actual needs, they evolved that. The topics we covered today gave us, at least, I hope so, those foundational elements.
So where do you, as an audience, go from here, right? And my suggestion would be focus on one of the areas that we've discussed that resonates with you the most. Start small, right? Experiment, break things, learn new things, and then build competency via expanding. And the second is connect with the community, right? Hands up in the audience, who's attending their first KubeCon?
Come to a second and a third and continue.
Right, so leverage the community. We're all here, we've all got our own battle scars from many, many different organizations, many different clusters. And we've all leveraged a multiple tooling options, right? So it's really about leveraging and building that connection and building that network. You can't possibly be an expert in the whole entire CNCF landscape because to start with, you have to actually zoom out on your browser to be able to see them all. And then I think the most important thing is your cloud native success is not measured by what fancy tooling you use or what version of Kubernetes or name any tool you're using. It's really about what are the business outcomes. Are you using technology as a driver to be able to drive business change and business value?
So today we spun the wheel on these topics, but your organization journey will follow its own path. The key is understanding that the landscape will be spinning blindly, so you're going to adapt to that. Cloud native is not about technology, it's about possibilities. Thank you for taking this journey with us today, and now go and spin your wheel of fortune. If you want, you come to the GitHub booth, and we have a real wheel to spin, and you can win some swag. and you can find me there after the talk. If you want to rate our talk, we have a QR code. And if you want to connect with us, we also have the QR code with our faces, which is really funny.
Thank you much for your time, and enjoy the rest of the conference.